assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Here for part A, we know that for the physical pendulum, we have that t, the period, is equaling 2 pi times the square root of the moment of inertia divided by mgh. And this would be equal to 2 pi. According to the parallel axis theorem, this would be equal to 2 pi times the square root of the moment of inertia through the center of mass plus mh squared. And this would be divided by, again, mgh. We know that we're going to substitute r for h and then use item I in table 10.2. So we can say I in table 10.2. And essentially we find that t is equal to 2 pi over the square root of g multiplied by the square root of a squared plus b squared divided by 12r plus r and extend the square root. So this would be our plotting t versus r, and we're going to use an a value of 0.35 meters and a b value of 0.45 meters. After plugging this in and then plotting, this would be the plot. This would be the period in seconds. This would be r in meters, and this would be what the plot should look like. For part B, now we find the minimum of it can be located by setting the derivative to 0. So we find the derivative of the period with respect to r, set this to 0, and essentially r now has to equal the square root of a squared plus b squared divided by 12. And we can use the same exact values, so that r is going to be square root of 0.35 meters quantity squared plus 0.45 meters quantity squared. And this would all be divided by 12. R is equaling 0.16 meters. And this makes sense because just based on here, 0.16 would be approximately right here. And that would be in fact the minimum period. So this would be our R value for the minimum t for part B. For part C, now we know that the direction of the center does not matter. So we can say that the locus of points is a circle around the center with a radius of, this would be a squared plus b squared divided by 12 all to the 1/2 power. So this would be our radius here for part C. That is the end of the solution. Thank you for watching.